In this video, we're going to be doing some half-life problems. This involves some calculations. Follow along on the half-life problem sheet. This is assignment 6. So just a review of the video, a half-life is the amount of time it takes for an element to decay into another element, for half of that element to decay into another element. So for example, let's say we have this purple element, and this is a bunch of elements. We will call this 100%. So we have 100% purple. And it is going to it's going to decay into red. Okay, so if the half-life was 1 minute, after 1 minute, half of it would now be the red element, no longer the purple element. This whole thing would now be red, and only half would be purple. After another minute, so 1 more minute, half of what's remaining has decayed into red, and we are left with only a quarter of the purple. After another minute, again, half of the purple that's remaining decays into red, and we're only left with an eighth. Okay, and so on. This can go on forever. So our first problem says, if the half-life of iridium-182 is 15 minutes, how much of a 1 gram sample is left after 45 minutes? In order to do this, we're going to create a table that has our original amount, the time, and the number of half-lives. So I've just abbreviated. The original amount I'm going to call my grams because that's going to be the mass of my sample. And then my time I'm abbreviating as T. This will be in minutes for this problem. And the number of half-lives. T 1/2 means half-lives, so I need to know how many half-lives have passed. So first I need to fill in the information that I'm given. I'm told that the half-life is 15 minutes. So if I have 0 half-lives, 0 time will pass because no half-lives have passed. But after 1 half-life, 15 minutes will pass. After another half-life, 30 minutes will pass because this is 1 half-life, 0 to 15. 15 to 30, we're adding another 15 minutes, so that's another half-life. Okay, and so on. I have a 1 gram sample, so initially I'm starting with 1 gram. So when 0 half-lives have passed, my time is 0, and I have started with 1 gram of my sample. So after 1 half-life, my sample is cut in half. So instead of having 1 gram, I now have 0.5 grams, right? 1 divided by 2 is 0.5. This is after 1 half-life. So this is after 15 minutes because my half-life is 15 minutes. Then after another 15 minutes, so a total of 30 minutes, I have cut my sample in half again. So now instead of 0.5, I have 0.25. Well, the question asks, how much is left after 45 minutes? Well, I'm not at 45 minutes yet, but if I go to 3 half-lives, so 1 half-life is 15 minutes, so 3 half-lives would be 45 minutes. So either you can think of it as you're multiplying the length of the half-life times the number of half-lives, or you're adding 1 more half-life every time. So this is plus 15, plus 15, plus 15. And both of those are the same. There are 2 different ways of thinking of the same thing. So if I'm cutting this in half again, instead of 0.25, I have 0.125 grams, and that would be my answer. Okay, pause the video and try number 1. So hopefully you paused the video and you tried to fill in all of the highlighted boxes. I'm going to walk through filling them in, and you should check your answers. So here we're told that the half-life of carbon-14 is 5,000 years. So T 1/2 equals 5,000 years. And we are starting with 200 grams. So the 200 grams is our starting amount. And we want to know how much is left after 10,000 years. So 10,000 years is the time we want to end up in. When you think about it, to go from 5,000 to 10,000, we're going to need 2 half-lives. So after 1 half-life has passed, we have, the length of our half-life is 5,000 years, so 5,000 years has passed. After 2 half-lives have passed, another 5,000 years have passed, so that would be 10,000 years, which is what we want to figure out. So after 1 half-life, we've cut this sample in half, so we're going to have 100 grams. And after our second half-life, we've cut this sample in half, so now we're going to have 50 grams. So there should be a total of 50 grams left after 10,000 years. Go ahead and complete the other 4 problems. Please make sure that you make a table, make it neatly, and then you'll take a picture of this and upload it onto Canvas. Or if you want, you can just complete the assignment virtually and then upload that document onto Canvas.